Okay, next theorem is interesting, important, and a little bit tricky. You have to keep your mind open so that you can understand it, because we will talk simultaneously a single element having its membership in some upper class and some lower class and other stuff. So theorem statement is, let B be a subclass of A, and suppose that lambda of B has supremum in A, then B has an infimum in A, and infimum of B is equal to supremum of lambda of B. Okay, you have to write its dual as well. I haven't written it, but what is its dual? It must be let B be a subclass of A, and suppose that lambda of B is replaced by nu of B, and suppose that nu of B has supremum is replaced by infimum in A, then B has supremum in A, and supremum of B is equal to infimum of nu of B. So it is its dual, and we don't have to prove it, but we have to prove this theorem. What we have in our hand, let B be a subclass of A. This is our information, and suppose that lambda of B means the class of lower bound of B has a supremum. Supremum is least upper bound, okay, in A. Then B has an infimum in A, and infimum of B is equal to supremum of lambda of B. We have to prove that infimum of B is equal to supremum of lambda of B. Again, infimum is before proving it, I have mentioned over here is infimum is generally called the GLB and supremum is called LUB. GLB means class, infimum is actually the class of lower bound, greatest element of the class of lower bound, okay. So obviously greatest and least elements are unique, so it must be a unique element. Lower class of lower bounds, if class of lower bounds has a greatest element, that is called infimum. If class of upper bound has a least element, then it is called supremum, okay. So we have to prove that infimum of B is equal to supremum of lambda of B. Now let us, because it's a single unique element, so let us suppose that A is equal to supremum of lambda of B. Instead of using supremum of lambda of B, we will just say A, because it's an element, it's an arbitrary element, so we can say that it's A. Okay, we have suppose that A is equal to supremum of lambda of B. If we can prove that A is equal to infimum of B, then we are done in our theorem, because if left hand side is equal to 0, then right hand side must be equal to 0. If we have proved that A is equal to infimum of B, so it means that infimum of B is actually equal to supremum of lambda of B. So our target is to prove that A is equal to infimum of B. It means that A is equal to greatest lower bound of B. So let's talk about B. Suppose B belongs to B. Suppose there is an element B belongs to. After supposing that A is equal to supremum of lambda of B, we will talk about the elements of B, because our target is that we will prove that A is equal to infimum of B. So we will talk about this class first, this class B. Take an element B belongs to B. For every C belongs to, take another element, for every C belongs to lambda of B, for every C belongs to lambda of B, it means that C must be less than or equal to B. C must be less than or equal to B. Why? Because lambda of B is actually the class of lower bound, and when an element belongs to this class of lower bound, so it means that this element is less than or equal to every element of this B, less than or equal to every single element of this B. And here in this case we have a single element B, so it means that this C is less than or equal to B, where B, from here we can say that, now we can read it as B is greater than or equal to C, means this B is greater than or equal to every element of lambda of B, vice versa, okay. So from here we can say that B is greater than or equal to C, means B is greater than or equal to every single element of lambda of B, so it means that B is an upper bound of lambda of B, okay. B is an upper bound of, now keep in mind that B is an upper bound of lambda of B. Okay, so from here we can say that A is less than or equal to B. Now how can we say that A is less than or equal to B? This is B is an upper bound of lambda of B, and A is actually in supremum. It means that LUB of lambda of B. LUB of lambda of B means least upper bound of lambda of B. A is the least element of upper bound of lambda of B. Now B is an upper bound of lambda of b, b is another upper bound of lambda of b, so it means that a is the least, so it means that a must be less than or equal to b. Okay, now this is true for each b belongs to b. This statement is true for each b belongs to b, so we conclude that a is less than or equal to b. Here, from here we can say that a is less than or equal to b, and this is true for each b belongs to b, so it means that a is less than or equal to every element of b. When a is less than or equal to every element of b, so it means that a is an infimum of b. A is the lower bound, sorry, infimum, not infimum, a is the lower bound of b. A is the lower bound of b. Half is done. Okay, a is the lower bound of b. Infimum means greatest lower bound. We have proved that a is the lower bound. Now we have to show that a is the greatest lower bound, and then we are done. So we have proved that a is infimum of, so we have proved that a is the lower bound of b. Now we have to show that A is the greatest lower bound. A is greatest among all the lower bounds. So for this, let us take an arbitrary lower bound of B. Now if D is any other lower bound of B, if D is lower bound of B, then D must belongs to the class of lower bound of B. So D belongs to lambda of B. From here we can say that A is greater than or equal to D, because A is an upper bound of lambda of B. Because A is an upper bound of lambda of B. So from here we can say that A is greater than or equal to D. And we have learned that A is greater than any other lower bound of B. So it means that A is the greatest lower bound of B. So we can write that A is equal to infimum of B. We have supposed that A is equal to supremum of lambda of B, and we have proved that A is equal to infimum of B. So it means that supremum of lambda of B is actually equal to infimum of B. This concludes our theorem. Take a deep look at it, and if you don't understand any of the statement, you can ask me. I'll explain.